In this lesson, we're going to switch gears a little bit, and we're going to talk about slope, and this is going to lead us actually into our next lesson where we talk about graphing lines using the slope and the y-intercept. For this video specifically, we're just focused on slope and different ways to find slope and what the slope actually means. So what a slope is how fast a line is moving. We talked about in the last lesson, you could find x-intercepts and y-intercepts to graph a line. There are other things that you could do to graph a line as well, and I showed you one example of that, and that was graphing using the slope and the y-intercept. The slope, like I said, is how fast a line is moving, upwards or downwards. It's the steepness of the line. So you see that this line right here is steeper than this line. That means it has a higher slope, a larger slope. Notice also that if you were moving from left to right, say you put a car on the left side of this, it is moving uphill. That's a positive slope. The same thing here. This car, if I put it on the left and move to the right, it's moving uphill, which is a positive slope. Slope, a lot of people remember from middle school, is known as, well, it is a change in y over change in x, but sort of the way that you remember it is rise over run. And so you always want to calculate your rise first and then calculate your run, and put that as a ratio, rise over run. That is your slope. So for example here, the park trail example. If we want to calculate our rise, how far did it rise? Change in y was 2 feet. Our run, change in x, is 6 feet. So 2 over 6 makes 1/3. The same thing in this example. We rise 5 feet. We run 4 feet. Up 5 over 4. So 5 over 4 is our slope. Notice that both of these, again, are positive slopes. If I put a car on the left side, it's moving upwards as I go to the right. And I can draw you a picture. If I had a line that was doing like this instead, my car would be going downhill, down a negative slope. There are two other options for slope that we're going to see a little bit later. If we have a flat line, say this is our x and y intercepts. If we have a flat line, horizontal line, that car is driving flat. It's not going up or down. That would be a slope of 0. Also, we could have a vertical line. If this is our x and y intercept and we have some vertical line, we couldn't put a car on that and drive straight up that cliff, so we would call that a slope of undefined. Undefined slope. So if we wanted to find the slope of these stairs, we want to determine the slope of these stairs. We know that slope is rise over run. We rise 8 feet. We run 16 feet. 8 over 16 is the same as 1 over 2. You might want to pause and try this one. If you wanted to find the slope of the aircraft's takeoff path, I'm going to again calculate it as rise over run. We rise 500 feet. We run 6,000 feet. And if we simplify that, that's the same thing as 5 over 60, or the same thing as 1 over 12. There is a formula. So on all these past examples, we're just given the rise and given the run. There is a formula. This is a formula you should write down in your notes. This formula that I have right here, y2 minus y1 over x2 minus x1. That's how you find the slope if you're given 2 points. Instead of given some information, if we're given 2 points in a coordinate plane, those points are x1, y1, that's supposed to be a point there, and x2, y2. If we're given those 2 points, we can find the slope between those 2 points by using the formula that I have starred here. Now, the note here says that because the denominator can't be 0, we can't divide by 0. If x2 minus x1 is 0, then our slope is undefined. If the x values are the same, then our slope is undefined. We'll see some examples of that later. Let's try to find the slope through these 2 points. It gives us 2 points here. I've written down my slope formula already. I've already written down this formula on several of these slides. We're going to keep using this formula. Anytime we have 2 points, that's the formula we're going to use. So this is my x1, y1, x2, y2. Remember, any point is a x comma y. Every point you have is a x comma y. They're alphabetical, w, x, y, z. X comes first, then y second. If I want to sub these into my formula, I'm just going to put them exactly where they go, including the negative signs. So -2 minus 3 over negative 4 minus negative 1. And then in my calculator, I'm going to type that top part in, negative 2 minus 3. Negative 4 minus negative 1. And then I'm going to, again, try and simplify that fraction. It simplifies to 5 over 3. 5 over 3 is my slope. If you wanted to graph that, you could. Negative 1, 3, negative 4, negative 2. And notice that this is a positive slope. Remember I was talking about earlier, if we put the car on the left side, it's traveling upwards as we go left to right. If it was a negative, if I had turned out to a negative number, I would expect my car to be traveling downwards. Try this one. You should pause the video. I'm going to count to 3, and then I'm going to reveal how I work this one. Again, I would label these x1, y1, x2, y2. Remember, every point is a x comma y. And so subbing those in, we get this. 3 minus 2 is 1. 1 minus negative 5 is 6. That's our slope, 1 over 6. Lines that increase, this is what I've been talking about at the same time. Lines that increase left to right are positive slope. Decrease left to right is a negative slope. If they don't increase or decrease, they're a 0 slope. And if you have a vertical line, try to drive your car up that hill. That is undefined. That's an undefined slope. This one, even though it has fractions, we're still going to work it the same exact way. We're going to put our y2 minus y1 over x2 minus x1. This is what that looks like. On the top, when I subtract negative 3/2 minus 1/2, I actually get a whole number, negative 2 over 7. This is the first we've had where we actually get a negative slope as our answer, and that's perfectly fine. Negative slope is a valid answer. Let's try this one. This one's going to be a little bit different. So if we sub in y2, again, this is x1, y1, x2, y2. If we sub in y2 minus y1 over x2 minus x1, we get 5 over 0. And since you cannot divide by 0, this is something I always tell people to trust their calculator. If you type that in the calculator, negative 5 divided by 0, you get a domain error or a divide by 0 error. We get an error. If the calculator tells you got an error, that means we have a slope of undefined. Our slope is undefined. We can't divide by 0, right? That's the main rule in math. That is the unbreakable rule in math. We can't divide by 0. Our slope is undefined. Always type these in your calculator at the end, either to make sure that it doesn't simplify right. You can use your calculator to simplify your fraction, or to make sure that you're not getting an undefined slope, right? A 0 slope is fine. We just don't want an undefined slope. Well, I mean, an undefined slope is an answer. We just don't want to say 5 over 0. That's not valid. All right, try this one. This is what happens when I sub my points in. Again, I get negative 8 over 0, which is undefined. This one also is going to work out a little bit differently. Let's try it. Here I say y2 minus y1, negative 2 minus negative 2 over negative 3.5 minus 3.4, and I actually get 0 over negative 6.9. If you type that in your calculator, that's just 0, and that is fine. Our slope equals 0. Slope is 0. This is going to help us in the next lesson when we get ready to graph, okay? It helps to know what a slope is, what the slope actually means. Remember that a slope of 0 means that we have some horizontal line. We have some horizontal line. Remember, the car has no resistance here. He's just moving left to right with no slope. Here's another one for you to try. That's what happened when I sub my values in. Again, I got 0 over negative 8, which is a 0 slope. Parallel and perpendicular lines. All right, so parallel lines are lines that just never touch. They carry on forever and they never touch. Notice these two lines that we have graphed here. These are parallel lines because no matter how far I went right or left, they're never going to touch. They're always going to be a little bit apart. And that's because they have the same slope. If you look at those two lines, notice that they go in exactly the same way. They're the same steepness. This one has a slope of 5 over 3. This one has a slope of 5 over 3. For lines to be parallel, they have to have the same slope. Parallel lines have to have the same slope. Specifically, they have to have the same slope. They also need to go through different points, right? And so obviously these go through different points. But this extra information here, different y-intercepts, they have to go through different points. There's the y-intercept, there's the y-intercept. Notice these hit different points, but they have the same slope. That's the key for this lesson. Parallel lines have the same slope. Perpendicular lines are lines that meet at a right angle. If we look here, those meet at a right angle. That's a 90-degree angle, okay? Perpendicular lines do intersect at a point. And the key to know whether lines are parallel or perpendicular, remember parallel lines have the exact same slope. Perpendicular lines have the opposite reciprocal slope. The opposite reciprocal slope. A reciprocal means you take a fraction and flip it. The opposite is talking about the sign, positive or negative. So if I took this slope, -4, if I wanted to make a perpendicular slope, I would have, this is the same as -4/1. I would call it positive 1/4. So we changed it from negative to positive, and we flipped it. If I had, for example, a slope of -3/5, my perpendicular slope would be positive 5/3. If I have a slope of positive 1/3, I would say my perpendicular slope is -3/1, or the same thing as -3. If we want to know whether lines are parallel or perpendicular, we need to look at their slope. We always need to look at their slope. If they have the same slope, they're parallel. If they have the opposite slope, they're perpendicular. And if they don't have the same or the opposite, they're just neither. We just say they're not either parallel or perpendicular. That's perfectly fine as well. This is a reminder of the same thing that the last slide was saying. For two parallel lines, their slopes are the same. The slope for line 1 is the same as the slope for line 2. For perpendicular lines, their slopes are opposite reciprocals, and so the slope of line 1, if we take it and make it into a fraction and change the sign, obviously, if we multiply those two things, we should get -1. So if I had a slope, for example, of 5/7 and a perpendicular slope of -7/5, if I multiply 5/7 times -7/5, I'll get -35/35, which is the same thing as -1. Anytime you multiply perpendicular slopes, you also get -1. It's okay for us to just remember for now, two slopes are perpendicular if they have the opposite sign and they're reciprocals. So suppose a line has a given slope of -6. We're given a slope of -6. If we want to find the slope of a line that's parallel, that slope will also be -6. It has to be the exact same. If we want to find the slope of a line that's perpendicular, that slope will be positive 1/6. The opposite reciprocal. Try this one. If we have a slope of 5/3, a parallel slope, what would that be? The exact same thing, 5/3. A perpendicular slope, what would that be? The opposite, so a negative, 3/5. All right, if we're given points, remember we can have 2 points and find the slope. If we want to know if these two lines, line 1 and line 2, are perpendicular, parallel, or neither, what we need to do is find their slopes. So here's what I'll do. For the blue part, I'm going to sub into my slope formula. y2 minus y1 over x2 minus x1. And then simplify. 1 minus -7 is 8. 4 minus 2 is 2. That simplifies to 4. So for line 1, I'm going to call this actually M1 for slope 1. All right, slope 2. This is key too. I didn't mention this earlier. A lot of times we will notate slope as M. M stands for slope in algebra, specifically with linear equations. M stands for slope. So here, M equals y2 minus y1. That's 0 minus 1 over 1 minus -3. That's -1/4. And let's compare these two slopes, 4 and -1/4. Are they the same? They're not the same, so they're not parallel. Are they the opposite? They are. Opposite signs. One's positive, one's negative. Are they reciprocals? Yes. 1/4 is the reciprocal of 4. So these are perpendicular lines. I should have mentioned earlier as well that this upside down T is the sign for perpendicular. Perpendicular. The sign for parallel is vertical bars. The sign for perpendicular is the lowercase t. Or, I'm sorry, I can say lowercase, it's the upside down t. If it's neither, we just have to say that they're neither. All right, try this one. The slope for line 1 is 1 over 3. The slope for line 2 is 1 over negative 3. Are they the exact same? They're not the exact same, so they're not parallel. Are they opposites? Yes, one's positive, one's negative. Are they reciprocals? No. We didn't flip that fraction, so they're not reciprocals. They're actually not perpendicular, so these are neither parallel nor perpendicular. They're neither. All right, last slide here, and this is something that I've actually already talked about. If we want to check if they're perpendicular, we can multiply the two slopes together. We should get -1. So for example, if on that last slide I had gotten m equals 1 over 3, and on the second line I had gotten m equals -3 over 1, if I multiply those two slopes, 1 over 3 times -3 over 1, I get -3 over 3, which is equal to -1. If I don't get -1 when I multiply them, then they are not perpendicular. They have to multiply to -1 to be perpendicular. That's the end of this, and remember in the next lesson what we're going to do is we're going to try to use this to graph lines. We're going to try and use the slope to graph lines.